Okay, today we're going to look at Chapter 10, Rational Equations and Applications. We're going to go with 10.3 today, and it's going to be on uniform motion problems. So with uniform motion problems, here we're going to look at a rate, a time, and a distance utilizing the formula. Distance is equal to the rate times the time. Now the distance values will be equal in both directions. So you're going to go one way, 8 kilometers, go back the other way, 8 kilometers. But the rates and the times are going to vary. So for this section, what we're going to do is we're going to use the formula in the following format, that the time is equal to the distance divided by the rate. So to set up a table, we're going to solve these problems with tables again. And so we'll have one direction, a second direction. You're going to have a distance each direction, a time each direction, and a rate each direction. And so you fill in the appropriate values. Usually they give you a distance, so you just put in a number here. The times, those vary. Sometimes it's going to be t and t plus 2, or we don't know anything. And the rates are going to be, one's going to be x, one's going to be x plus 3 or x minus 3 or something like that. And so we're going to try to work these out to fill in the table to make it the most efficient way to solve the problem. All right, so this one we have the rate of a current in a stream is 3 kilometers per hour. A man rode upstream for 3 kilometers and then returned back to where he started. Now the round trip required 1 hour, 20 minutes. How fast was he rowing? All right, so, if we draw a picture, kind of what we have, some kind of a stream here, we know that if this is the way the stream is flowing, that's 3 kilometers per hour going that direction. Now, it says he rode upstream for 3 kilometers, so he's going to go this direction against it for 3 kilometers. So the distance is equal to 3. And so what his rate is, well, his rate is going to be some x value, and then we base it on the stream speed. Well, he's going against it, so it's going to be x minus 3. That's going to be his rate. Now, when he turns around and goes back the other direction, he's going to go this way now. Well, now his rate is, in still water is x, and he's going to add 3 because he's going to go with the stream, so it's going to 3 kilometers per hour faster. Okay, so we're going to say his distance is 3. We're going to say x is equal to still water speed. Okay, and so now we can make a table. Rate, the time, and the distance. Well, the distance we know is 3 and 3. Now, what else do we know? Well, we know if this is going to be against first and then with afterwards, the against, we're going to have our rate as x minus 3. And here with is going to be x plus 3. Now we have to kind of decide which way we want to go here. Since with is going faster, let's call this t. Okay, so that's the speed width, so it's going to be that. And then the time for the other one, well, how long is 1 hour and 20 minutes? Well, 1 hour and 20 minutes is 1 hour, and then 20 minutes is 1/3 of an hour, and so that's going to be 4/3 of an hour. So the total time for against is going to be 4/3 minus however long it is with. Now we could have gone vice versa and done it either way, but I think this is the way that I'm going to do it here. Now, what I want to do is, like it shows in our initial thing, we want to solve for t for both of them. And the bottom one's easier, of course, because that's just t is equal to 3 over x plus 3. Now this one, I'm just going to solve for the 4/3 minus t is equal to what? Well, that's equal to 3 over x minus 3. Now notice I've got a t here and a t here. Those t's are going to be the same no matter what. So that means if I have this t is equal to this, I can plug in this value here into that, and then I can solve because then I only have one variable, x. Okay, so let's go down here. So we have 4/3 minus, now we have that 3 over x plus 3 equals, and then we have 3 over x minus 3. Okay. Now this is just a bunch of rational expressions, and so we know that if we multiply by the LCD, well, what is the LCD here? Well, LCD is 3 times x plus 3 times x minus 3. And so we're going to multiply this by that as well. And now we take each term and multiply, and then we write down what we have. So when we do the first one, the 3's cancel, so we'll have 4 times x plus 3, x minus 3. And then minus 3 times, well here x plus 3 cancels, so we'll have a 3 times x minus 3. And then that equals, now the x minus 3's cancel, and so we'll have a 3 times x plus 3. Okay. Now, x plus 3 times x minus 3, that's one of those nice ones. It's a difference of squares is what you get. You're going to get x squared minus 9. Okay, so we're taking 4 times that minus, and now here we have 9 times x minus 3 equals, here we have 9 times x plus 3. So this gives us 4x squared minus 36, and we have minus 9x, then plus 27 equals 9x, then plus 27. All right. Well, if we have the same thing on both sides, remember they cancel, because when you subtract the 27 here and subtract the 27 here, those cancel. So we get rid of those directly. We don't even have to worry about those. And so now all we have to do is subtract 9x. Okay, so when we get that, we'll go back up here. We'll have 4x squared, and then we have minus 9x is minus 18x, and then we have minus 36. And on the right side, when we subtracted everything off, we get 0. Now, on a lot of these, we use on the rate problems and things like that, we just use that initial term, the 4. Now, if we notice, we could divide out by 2 and simplify this a little bit better, but I'm just going to go and act like I don't notice I can factor out a 2. So what I could really do is I could multiply this by 1/2, and I would get 2x squared minus 9x, and then minus 18. And that might make it a little bit easier to work with in this, but I'm just going to say, okay, well, I don't see that, because a lot of students won't see that there's a common factor. Now, some of them, it makes it so much easier to do, but this one, it really is not too bad. So that's going to give me 4x and x, and again, I'm just using that initial value. And now the factors of 36. Well, the first ones that come to my mind are 6 and 6, so I'm just going to plug those in and see what we get. And so I need a negative 18, so I have a 24, then minus 6. Well, that's going to give me 18, so I need a negative here, a plus here. Now notice, if I had factored out a 2, that would have been a 2x and a 3, and that would be, that would be where it made it easier. But I can set each of those terms equal to 0, as a 4x plus 6 equals 0, and x minus 6 equals 0. Here we get x equals 6. Here we get x equals, subtract 6 is going to be a minus 6 over 4, so that's a minus 3 over 2. Okay, well, what do we know about speeds? Well, we're not going to have a negative speed, so that one we throw away. And so we want the speed in Stillwater. How fast was he rowing? Well, he was rowing 6, and it was kilometers per hour. And so that was his speed in Stillwater, and that's what they're asking for. Now, if they had asked how fast it was in each direction, that means this is going to be 6 minus 3, so that's going to be 3 kilometers per hour going that way, and this way is going to be going 9 kilometers per hour, because you're going to take 6 plus 3 and get that one. So we can see what the final values are for each of them, but all they wanted was the speed in Stillwater. All right, what about this one? We have 2 drivers testing the same model car at speeds that differ by 20 kilometers per hour. The one driving the slower rate drives only 70 kilometers down the speedway and then returns by the same route. The one driving at the faster rate drives 76 kilometers down the speedway and then returns by the same route. Both drivers leave at the same time, and the faster car returns a half hour earlier than the slower car. What rates were the cars driven? Okay, so this one, what we have to think about is, the one went down 70 and then back down this way 70. So the total trip was 140. The other one went down 76, came back down 76. So they went a total of 152. So that's kind of one thing we need to think about. The other one, we know that one is going to go X miles per hour, and the other one's going to go X, and then we'll say plus 20 miles per hour. And then one was returned a half hour earlier, so it was half an hour quicker. And so that one's going to depend on how we set up our table. So let's start working on our table. So we're going to have a rate, we're going to have a time, and we're going to have a distance. So we have our distances. We have 140 and we have 152. Okay. Now 152, that's going the longer one, and it's the faster car. So let's put that one here. So our rate there is going to be X plus 20. And since it was half an hour shorter, we'll take the total time minus the half hour. So that means on this one, we're going to say that that rate is just X and that this time is just T. Okay. And so, you know, this one's going 20 kilometers per hour faster. It took a half hour less, but it went 152 kilometers. This one went at rate X and for a time T for 140 kilometers. So now we're going to solve both of those for T again. So here T is equal to 140 over X. And again, you could use R or whatever, but I just use X just because it's the variable we're used to. And that's T minus 1/2 is equal to, and then we have 152 over X plus 20. Now here, I have T, here I have T minus 1/2. So what I'm going to do is I'm going to take this value here, and I'm going to plug it in here. Okay, and so then that gives me 140 over X minus 1 over 2 equals 152 over X plus 20. And now I multiply by the LCD. Well, what is the LCD? Well, that's going to be 2 times X plus 20. So that's what I'm going to multiply by. And I'm going to multiply each term times that. And so when I take that, I'm going to have 140 times, well, the X's cancel, so I'm going to have times 2 times X plus 20. Then minus, I have, well, 1 is 1. And then when a 2's cancel, I have X times X plus 20. And that equals, now the X plus 20, and I have 2 times 2X. Okay. So now I simplify here, that's going to give me 280x. Then I'll have 280 times 20, which is 5,600. Then I'll have minus x squared minus 20x equals, now 2 times that's going to be 304x. Okay. Now I think I've got everything here. So now I've got a negative x squared here. So I'm going to take everything to the right. So if I think about that, I have 280 minus 20. So I'm going to subtract 260x here. So I'll subtract 260x here. I'm going to subtract 5,600 here. So I'll subtract 5,600 here. And here I'm going to add x squared. So I'll add an x squared. All right, so now I've got 0 on this side because that was here and I got the 260 equals, now I've got x squared, and then 260 from that is going to be, it looks like 44x, and then minus 5,600. Okay, all right. Now, two factors of 5,600 that go into 44. If I try 56 and 100, and I subtract those, that's 44. So it's 56 times 100. So sometimes you're going to get it easy. You just take 56 times 100 to get 5,600. Sometimes you're going to have to work for it. So we said it was going to be plus 100 minus 56 because we needed a positive 44. So x plus 100 equals 0, and x minus 56 equals 0, setting each of our factors equal to 0. So x equals a negative 100 and x equals 56. Well, we're not going to have a negative 100 again. So x is equal to 56. So that's the speed, and this is the slower car. If we remember, that's the slower, that's the faster. So the slower is equal to 56 kilometers per hour, and the faster is 20 kilometers per hour, so that's 76 kilometers per hour. Okay, and that's what they're asking for. What are the rates of the two cars? So those are the rates that we have. All right, so that's all we need to have for our answer. All right, let's try some more. So here we have an automobile going to a place 72 miles away, then it returns, and the round trip occupies 9 hours. His speed in returning is 12 miles per hour faster than his speed going. Find the rate of the speed going and returning. All right, so what do we know? Well, let's write down our formula. Rate times time is equal to distance. Well, we know the distance both directions is 72, okay? So it says when he comes back, he's going faster. So let's say our rate going is x, and then let's just say this is t. That way it's simplified. You know, we have x and we have a t because we know the total time. So what we can say is coming back, we had x plus 12. We know the total time is 9. So if we had this much here, we're going to have 9 minus t for this one. Now we've got everything in our table filled in, and we can go ahead and solve for this column here. So on the first one, t is equal to 72 over x. And the next one, we have 9 minus t is equal to 72 over x plus 12. Okay. Now again, we have one of them solved for t, so we can plug that right in there. And when we do that, we'll have 9 minus, and then that's going to be 72 over x equals, and we still have 72 over x plus 12. All right. Now, our LCD, well, our LCD is equal to just x times x plus 12. So we're going to take this times x plus 12. Now, when we do that, nothing cancels here. So we're going to have 9x times x plus 12. Minus, now here the x's cancel, so we have 72 times x plus 12, and that equals, now the x plus 12's cancel, so we have 72x. Now we're going to need a calculator here when we multiply, so 9x times x is going to give us 9x squared, and then plus, now we have x, and then we have 9 times 12, so 9 times 12 is going to be 108x. Then we'll have minus here, that's 72x, and 72 times 12 is going to be minus 864, it says on my calculator. That equals 72x. All right, so now I need to get everything on the left side. So that means I'm going to subtract 72x. I'm going to subtract 72x. So what do I have? Well, I have 9x squared. Now I have 108 minus 72 minus 72. So that's going to give me a minus 36x, then minus 864 equals 0. All right, so these are big numbers with 9s. So let's see, 864 divided by 9 is going to give me 96, so that will work. So I can multiply everything by 1 over 9. And when I do that, I get x squared minus 4x, and then I had, what was it, minus 96 equals 0. Now, this is going to be a little bit easier, hopefully, to factor than this one. And so I'll have x and I'll have x. And factors of 96. Let's see, we can break that down. Let's see, 3 doesn't, 4, 8, 1, 2, 8 and 2, yeah, that's it. 8 and 12. I want a minus 12, a plus 8. So that gives me x plus 8 equals 0 and x minus 12 equals 0, which says x is equal to 12 or x is equal to a negative 8. Well, speed, we're not going to have negative, so that one's out. And so here we have x, so that's going to be the rate going, which is slower. And so that's going to be 12, and we're in miles per hour in this one. And the faster is going to be 12 miles per hour faster than that, so 12 plus 12 is 24 miles per hour.